Hi everybody, this is the section H-6. We're going to talk about something called vectors. And we're going to use vectors in some problems here. So what the heck is a vector? What does that have to do with trigonometry? Well, it does involve a little bit of trigonometry. A vector is basically a force, and it's represented by an arrow with a direction and a magnitude. It has a length. So a vector is really nothing more than a distance in a particular direction. The vector has an initial point and a terminating point. So it's an arrow, and it has a starting point, like right here, and it has an ending point. It's not a ray. A ray goes on forever. This stops right there. But the arrow just simply says that we start over here and we stop right there. So it's a little bit different. It's got a magnitude. Okay, so what we can do is we can talk about vectors in certain forms. So one of the forms is called compass directions. Compass directions would be, in the case of this vector, which starts here and goes that direction, is the length of that vector is 13, and in this particular context, we're saying it's in miles per hour. So a lot of times vectors deal with speed of something. So the speed of the wind, let's say, is 13 miles per hour, and the direction it's going is 22.6, and it's going actually north of this direction. This is east. If you think of your compass direction as north, south, east, west, this vector is going at an angle, kind of up in there, because it's going at an angle here. It is 22.6 degrees north of east. So we say north of east is the compass direction, and then we put the angle in there. So it's going at 13 miles an hour. That's the speed, the magnitude of the vector, and then the direction of the vector is 22.6 degrees, and that's north of east. And so we'll have some that are moved around a little bit. This exact same situation can be put in what they call component form. In other words, what would this ordered pair be if this ordered pair was 0, 0? This ordered pair would be 12, 5. We use this kind of strange looking bracket to identify a vector. So the 12, 5 is an ordered pair, but we don't use the comma or the parentheses. We use this kind of jagged bracket to identify the components of the vector. And we're going to convert these around, and so you want to have these in your notes as well. So we're going to convert from compass form to component form. So we're simply going to take x will equal r, and r is the magnitude of the vector. That's r right there. The magnitude of the vector times the cosine of the angle, and the angle would be this angle. And the y would be r times the sine of that angle. If we wanted to go from component form back to compass form, we would use r equals the square root of x squared plus y squared, and theta would equal the inverse tangent of the y over the x value. And you want to be really, really careful about what quadrant you're working in, because these answers could be positive and negative, and you may miss that in the calculating. So that's kind of an important thing. So again, we're looking at compass directions, and we're looking at component form of identifying the forms of the vector. So there's the notes. Let's stop here, and then we'll take a look at some examples in the next video.